So this is our graph. Okay. So remember that the base is going to change, but that's not a transformation. That just gives you what the base is of the parent function. Okay. All the horizontal stuff now happens in the exponent, and then everything in front of the function, or if anything was being added or subtracted after the function, would be vertical stuff. Okay. Does that make sense to everybody? Right. So just like before, this is all the horizontal stuff. These are all vertical things. Okay. So in our graph, there's not going to be any horizontal transformations. Okay. And then there's going to be these two things, the negative and the 3. What does the negative do? Reflection. And because it's out here and not up here in the exponent, what kind of reflection is it? The horizontal stuff happens in the function, and in this case, that means in the exponent. So because that negative is not in the exponent, it's not horizontal, so this will be a vertical reflection. And then what will the 3 do? So first of all, is it vertical or horizontal? Vertical because it's out here and not up in the exponent. Okay, so it's vertical. And remember, the vertical stuff, you actually multiply by the same exact number that's there. So you're really timesing things by 3. When you times them by 3, do they get bigger or smaller? Bigger. So that means stretch. Okay. So those are the two transformations. Okay. So the first thing I would want to do, I just have 2 graphs up here so that when one gets really messy, I can switch to using the other one, because sometimes these have more transformations. First thing we want to do is we want to put the parent function on the graph. Okay? So for all the exponential functions, the one thing that's consistent, or 2 things that are consistent, is there's an asymptote across the x-axis, and then it has this point at 0, 1. And then the curve can go from down to up or up to down, depending on what the number is right here. So when the number is 2, you need to build a couple more exact points to have your parent function. So my advice, plug in 1 and -1 each time as your exponents. Okay? So when we plug in 1, 2 to the first power is just 2. And what about when we plug in -1? What's 2 to the power of -1? What does it equal? 2 to the power of -1. 1/2. Okay? So here. So then you have 3 points to start with. Okay? You know your curve looks something like this. That's just my parent function. Okay? So I graphed this as my parent function. Again, the consistent things were that the asymptote was right here at y equals 0, that this point was our vertex point, and I plotted 1 point on each side of it. Okay? And then I have my curve. Now I'm going to do these 2 things to the graph to get where my new points are. Okay? The directions are maybe a little bit different than what we did before. We have to find the vertex. That was something we always had to do. We have to graph and list the transformations. So those things are the same. We also have to find 2 other points besides the vertex, and we have to find the y-intercept when we're done. So we might want to keep track of our points. So like right now, our vertex point is at 0, 1. It's going to start that way for every exponential graph. And the other 2 points that we graphed, we said when we plug in 1, we got 2. When we plug in -1, we got 1/2. Okay? I'm just going to keep track of them as we go, so it's not hard for me at the end if I did like some fractional thing to remember what was the fraction and where did it end up. Okay? So the first thing I'm going to do is the reflections. Remember that it's probably beneficial for you to do the reflections before you shift. That way you don't end up with things in the wrong place. So what is the graph going to look like when I vertically reflect it? Good. It's just going to go downwards. So everything that was above the axis is now going below the axis, including that vertex point, remember, okay, because it's not the same exactly as the functions we had before. So instead of this point being at 0, 1, it's now going to be at 0, -1, okay? So this text just changed positions to that point, okay? Instead of this point being at 1, 2, it's going to be at 1, -2. And then instead of this point being at -1, +1/2, it'll be at -1, -1/2. So doing the points might actually help some of you that struggled before with the transformations. If you know it's a vertical reflection, you know it's affecting the y coordinate. of the points, and you can see that all the x coordinates of our points stayed the same, and all the y coordinates got changed to the opposite when we did a reflection, like they got multiplied by a negative. Okay? All right, so now our graph looks like this. And so then the last transformation we have to do is we have to vertically stretch it. Okay? So then this is where it's different than what we did before. We have to make a decision. Are we stretching from the vertex, or are we stretching from the asymptote? So remember, our rule of thumb is going to be if you can measure from the asymptote, stretch from the asymptote. If not, then use the vertex. So can you measure these 3 points that you have marked on the graph? Can you measure how far they are vertically, so just vertically, from the asymptote? Okay? So like when I point to this part, can you tell me a number? How far is it from the asymptote vertically? 1 unit, right? If you can give me that number, you can measure from the asymptote, then your stretch is going to be from the asymptote. Okay? So we're going to stretch from the asymptote. So because we're not going to shift up and down, our final graph will have our asymptote in the same place that it was. And then let's look at each point. Okay? So this point right here, okay? What's its current vertical distance from the asymptote? So right now, this point is 1 space from the asymptote, right? Okay, negative. We won't move it up instead. We'll keep it negative. You're going to times that by 3. So what's 1 times 3? 3. So you're now going to replot this point, not 3 from where it was, but 3 from the asymptote instead of 1 from the asymptote. So it was here, okay, at 1. I'm going to 1, 2, 3. I'm plotting that point so that it's now 3 units from the asymptote instead of 1. And that means my vertex, its final location is at 0, -3. Okay. This is kind of why I kept track while we go, because the answer wants some points, and so it's easier for me to do it as we go. So I need to do that with each of the other points. So this point right here, how far was it from the asymptote vertically? 2. So when that gets multiplied by 3, 6. So that point in that position needs to be moved so that it's 6 units vertically from the asymptote. So it's going to be down there. Okay. So this point that was at 1, -2 ends up at 1, -6. Okay. And then finally, this point here was only half a unit, okay, from the asymptote. What do you get when you take half and multiply it by 3? Yeah, 1.5 or 3 halves. So I'm going to replot that point, so it's 1.5 or 3 halves unit from the asymptote. Okay. So this point ended up now being at -1, -3 halves, or you could write -1.5, that's fine. Okay. And then I will draw my graph going through those 3 points. Okay. Is this all right with everybody? All right. So very similar to what we did when we were graphing with transformations, except for parent takes a little more work, and we've got to think a little bit harder about our stretches and compressions. So at the end, the things that you should be able to write. Did we graph the equation? Yes. Do we have the vertex? Yes. Did we name the asymptote? Yes. Did we find 2 other points? Yes. Did we find the y-intercept? No. So we do need to write that. So what is the y-intercept of this graph? Yeah, so on the y-axis, we can see it's this point right here that ended up at 0, -3. Okay. Stephen, you had a question? Mm-hmm. Yeah. Well, the reflection, yeah. So the idea is it's all going to work the same. The only difference here is what you stretch from. So in our previous graphs, we always had a point at 0, 0. And we always stretched and compressed from that same point every time. If this graph had had a horizontal stretch, we wouldn't have measured from the asymptote. We would have kept the vertex in the same place and then stretched from that point. But otherwise, yeah, it all works the same as it did before. Uh-huh. Right. Exactly. Yeah. So if we can catch on to those 2 differences and you were good at what you did before, you're going to be doing the same thing here. Okay? All right. Tell you what, we'll do one more, okay? And then there's 6 problems that you guys need to do. I'll say by Tuesday. I don't really care. But I'll let you guys work on them, those of you that want to get it done so that you don't have to do anything, okay? Yeah, so let's do this one. This one will work. Can you guys see it? Yeah. Okay, so the only reason I wanted to do a different one is in the last problem, we didn't see anything that had any sort of horizontal stretches or compressions or things like that. This problem definitely has them, and the reason I know it has them is because of the way there's a bunch of stuff happening in the exponent. Okay? And I would actually remember, oops, not what I want to do. I would want to rewrite it. Remember, anytime you have something in front of x multiplying it, rewrite this part with that number just factored out. So, for example, I still want to write this as 1/2 to a power, but I want to separate the power into -3 times x minus 1 and minus 1. Because if I would have looked at this originally, I would have thought the +3 was telling me the horizontal shift. Okay? But it really has to do with 1 unit instead of 3 units. Okay? All right, so parent function. Okay? 2 consistent things every exponential parent function has. Asymptote at y equals 0. And a point at 0, 1. Okay, so this graph I'm making right now is if none of the changes existed, but we were just graphing 1/2 to the power of x. Alexis? Because anything to the 0 power is 1. So, like, since we're only dealing with exponent stuff, we'd always be plugging it in there. So remember, I'm graphing this right now. Like, if all the changes and crazy stuff didn't exist in the equation, it was much simpler like this. Okay. Then the things that are a little bit different are when I plug in 1 and -1. Okay? So what do I get when I plug in 1? What's 1/2 to the power of 1? What's 1/2 to the power of 1, people? 1/2. Okay, so 1/2. All right, what if I plug in a power of -1? 2, because it flips over the 1/2, right? So these are the 3 starting points I'm going to have, which means my graph goes like this. Okay, so all exponential graphs start with some curve like that, asymptote here, point at 0, 1, and then we plug in a couple things to get the points around it. Okay? And again, I'll keep track of my points. So right now I know the vertex point is at 0, 1. It's kind of always where it starts for the exponential ones. The other 2 points we got in this case were the points 1, 1/2 and -1, 2. Steven? Yeah, I would get the vertex and probably do 1 on each side so that you can see the shape better. All right, so let's list out the transformations so we know what we're going to have to do next. So what are the transformations? What is this going to do, this negative that's multiplying up here in the exponent part? Good. Okay, so horizontal reflection this time. Okay. What about the 3 that's next to it? So again, horizontal, because it's all up in the exponent. And then remember, the horizontal stuff is crazy. It says times 3, but what do we really multiply by when it's horizontal? 1/3, yeah. Which, if you multiply stuff by 1/3, does it get bigger or smaller? Smaller, so we'll call this a compression and not a stretch. Okay. So I like to do that every time. It helps keep it straight for me. If I can write down the number to multiply by, I know whether to write the word stretch or compression next to it. Okay. So then the last thing in the exponent is this x minus 1. What is that going to do to our graph? Move it to the right one, okay? Again, it's horizontal because it's all up there in the exponent. Okay, and what about the -1 that's at the end of the equation outside of the exponent? Down 1. So our only vertical change is to move everything down 1. Okay, so here's all of our transformations. Our asymptote starts at y equals 0, our vertex point, and 2 other points. Okay. All right, so let's go ahead and do this stuff. So horizontal reflection. Am I going to flip it over the asymptote? Would that be horizontal? No. Above to below would be vertical. So horizontal means left and right, which I can't really use the asymptote for reference there. So that's when our vertex comes in handy. So that point's going to stay this point's going to end up on the left side instead of the right side, and the point that was on the left is going to end up on the right. So we now see the curve go like this. That makes sense to everybody as a horizontal reflection. Things switch from left to right. Okay, so what happened to our points? The vertex still stayed at 0, 1. It didn't change. Okay. What about the point that was at 1, 1/2? Yeah, now it's -1, 1/2. So the x-coordinate basically became negative. And the point that was at -1, 2 is now at +1, 2. Okay, so that's how the coordinates have changed. Again, you don't have to do this, but sometimes when you have like weird fractions and stuff, like this 1/3 that might show up, it's easier to keep track as you go than try to like figure out at the end where that point ended up after you shifted it and stretched it and did all this other kind of stuff. Okay. All right, so next thing we want to do is we want to horizontally compress it by 1/3. So are we using the asymptote as our reference? So when you look at a point in this graph, can you measure how far it is from the asymptote horizontally? No, from point to asymptote is a vertical distance. That means we're not using the asymptote this time. We're using the vertex. So the vertex point is going to stay where it is because everything is going to get measured from that point. And then the horizontal distances are going to get multiplied by 1/3. So this point right here, okay, how far is it right now from the vertex point horizontally? 1 unit. When 1 gets multiplied by 1/3, 1 times 1/3 would be 1/3. I'm going to replot this point so it's only like, I can't be very accurate, neither probably can you, but it's 1/3 of a unit away from it. So it's getting really squished close to it. Okay? The same idea here. This point is also 1 unit horizontally from the vertex. 1 times 1/3 would be 1/3. I'm going to replot it so it's only 1/3 of a unit from the vertex. So everything got squished together horizontally. Okay? And this is where it comes in handy to keep track of your points as you go. Did the vertex point change? No. This point that was at -1, 1/2 is now over here at -1/3, 1/2. Okay? Because I moved it so it was only 1/3 of a unit away from this one. So if this one was at 0, that's -1/3. This one's also only 1/3 of a unit away. So if this is at 0, that one's at +1/3. So the point would be like 1/3, 2. Okay. All right, now I want to move everything to the right 1 unit. So I'm just going to go ahead and move everything to the right 1 unit. The asymptote, it doesn't have to move it right or left. It goes infinitely in both directions, so it kind of just stays there. So the vertex point now moves here. Okay, instead of at 0, 1, it's now at 1, 1. Okay? And remember, each of the other points was 1/3 away from it. So this point's going to move right here. What is the x-coordinate of this point if it's 1/3 of a unit right before 1? 2/3, because 2/3 is 1/3 before you get to 1. Okay? So then this point would be 2/3, 1/2. Okay? And then this point that's 1/3 of a unit after the vertex is now at 1, so this would be like 1 1/3, 2. Okay? So everything moved to the right. I can't apparently draw through points today. There you go. Okay? So the last thing you have to do is move everything down 1, and that will be our final graph. So when we move everything down 1, okay, where's our asymptote going to be? -1. Okay, so when things move up and down, so do the asymptotes. So our asymptote is going to be here now because it moved down 1. It's going to be at y equals -1. Okay, and then all the points are just going to move down 1. Okay, so this point was at 1, 1. We're going to move it down 1, so it's going to be at 1, 0. Okay. This point was at 2/3, 1/2. We're going to move it down 1. And again, the points might help you if you're really struggling in this case. So our vertex was at 1, 1. If you move it down 1, remember you're basically subtracting 1 from the y-coordinate. So 1 minus 1 makes that equal to 0. So you can see why the vertex is at 1, 0. Okay. If we move this next point down one, if you're struggling with the coordinates, look at the y coordinate. What do you get if you take 1/2 and you subtract 1 from it? So you would get negative 1/2. So that point's at 2/3 negative 1/2. And then with this coordinate point right here, so you had 1 1/3, comma 2. You're moving it down 1, so subtract 1 from the y coordinate. That point's going to be 1 1/3, comma 1. So this would be our graph. So do we have everything that they asked us for? So the transformations are over there. The asymptote is here, the vertex and 2 other points. And then the only issue is the y-intercept. Okay? Can we see the y-intercept really clearly on our graph? No. I mean, we can see where it goes through, but we have no idea what point it is. Do you remember how you find a y-intercept algebraically? You do the same thing every time, no matter how crazy the equation. What do you plug into the equation to find a y-intercept? 0 for what? X. Because if a point is on the y-axis, what does the x-coordinate have to be for that point? 0. So if we can't see the y-intercept from our graph, we could find it algebraically by taking our equation and plugging in 0 for x. Okay? So negative 3 times 0 would be 0, plus 1/3 would just be 1/3. Sorry, it didn't say plus 1/3. It said plus 3. I just have a problem today, so I wrote 1/3. Okay, 1/2 to the 1/3 power would be 1/8. And then you could do the arithmetic to do 1/8 minus 1. You would get like negative 7/8. So our y-intercept is the point 0, negative 7/8, which probably would have been impossible for you to figure out after just sketching the graph on your own. Okay? So it's all right with everybody? Same thing we did basically in Unit 2, all the transformations, except for you have this asymptote that could possibly be measured from, and you have to be a little more careful getting the parent function at the beginning. Okay?